Good morning. I'm going to begin a mini series on alternative perspectives on superposition and quantum computing, and here I just introduce some ideas. Now let's begin with this notion in normal computing where we have one bit that can be either representing a 0 or a 1 state, and then in quantum computing we have one qubit that in addition to 0, 1 can also be in a superposed state of 0 and 1. And the implication of this is that suppose we have an n qubit quantum computer, that this quantum computer can simultaneously be in 2 to the power of n states, as opposed to a regular computer that would be in only one state. And this is the draw, the real attraction of the quantum computers, is that they can supposedly represent a much higher degree of information with just a smaller amount of hardware, if you will. But let's think about this in a little more detail. So when we're talking about the quantum realm, we're talking about that realm where electrons or matter or light is simultaneously in both a particle and a wave state. So let's unpack this notion of particle and wave. So if we think about a particle, then we can see that that's a property of this world in which the upper limit of light is c, the speed of light is c. So we have a certain upper limit, and in this world nothing can exceed the speed of light. So that implies we also have a lower limit, and the lower limit is such that it's the inverse of this. And this is something, this quantity 1 over c is known as Planck's constant. And we know that matter, the fact that matter can form is a result of this lower limit, because energy can express itself only in quanta, which means that there's a stability by which matter can continue to exist and not dissipate itself. But when we think about a wave, then what that implies is that this quantity here is getting drastically reduced, and it's getting reduced so that energy can then disperse itself, so matter cannot form, and therefore a wave may emerge instead. And what this implies, if this is getting reduced, this implies that we have the speed of light in this wave world, which would be much greater than c, which is the speed of light in our physical world. So now the implication of this for superposition is that we fundamentally have two different realities. So we're saying that where that wave exists, we have light which is far greater than the speed of light at the physical reality. And what that implies is that there likely has to be a different approach to really represent the superposed state. So right now there's kind of a simplicity in our assumption that we take the number of possible states from the physical world and we just extrapolate and say that that's what a superposed state represents, or the possibilities of a superposed state. But in reality, what this implies is that there's going to have to be a whole different thinking about what that superposed state is. And in subsequent explorations, we can begin to look at what might be these different realities here versus here, and just a simple extrapolation. So if we have, for instance, the speed of light in this wave world greater than the speed of light p, we can extrapolate this trend and say that there's likely a place where the speed of light is infinite, and there's going to be different kinds of worlds or physical realities, or realities that emanate from this. So here, for instance, we know that when we have a finite speed of light, then the finiteness itself creates both matter and it creates a sense of past, present, and future by virtue of light taking a finite amount of time to get from X to Y. Now, if we look at the reality that emanates from light traveling faster than the speed of light here, then we have, rather than a wave, we have, rather than matter, we have waves that exist in that kind of world, and we have a melding of past, present, and future. And if we extrapolate further in this world where we have the speed of light being infinite, we have a kind of a oneness where instantaneously everything is connected to everything else. Intelligence knows itself fully, and that reality knows anything about itself in any space and time. So we can already see that there's a whole different set of realities that is possible, and in this exploration we would also need to re-examine fundamentals. So a different interpretation of Schrödinger's equation, different interpretation for Heisenberg's uncertainty principle, which is a cornerstone of today's thinking about quantum reality. And I would bucket all this in one category where we're rethinking about the realities that create these superposed worlds. Second, we would need an alternative mathematical model to represent, in a sense, these superposed worlds of where we have the speed of light at the physical level, speed of light in waveforms, speed of light infinite. And thirdly, what this implies is a whole different technology to access the superposed state and potentially to think about quantum computing.